Theoretical recap. A subnet, subnetwork, is a logical subdivision of an IP network. The core tool for defining subnets is CIDR, Classless Inter-Domain Routing, notation, written as an IP address followed by a prefix length, for example, 192.168.1.0 out of 24. The prefix length tells you how many bits are reserved for the network portion, leaving the rest for hosts. A /24 gives you 256 addresses, 254 usable hosts. A /26 gives 64 addresses, 62 usable hosts. A /28 gives 16 addresses, 14 usable hosts, and so on. The fundamental formula is usable hosts equals 2/32, prefix, 2, subtracting network and broadcast addresses. A common mental model. Think of the prefix as a zoom level on a map. The larger the prefix number, the more zoomed in you are. Fewer hosts, smaller network. The most frequent mistakes beginners make are forgetting to subtract 2 from the host count, confusing the network address with the first usable host, and choosing a subnet that is either too large, wasting addresses, or too small, blocking future growth. Mini example. A team of 30 workstations needs its own subnet. A /26, 62 usable hosts, fits perfectly. A /27, 30 usable hosts, is technically exact but leaves zero room for growth, while a /24 wastes over 200 addresses. Choosing the right prefix is always a balance between current need and anticipated growth. Workshop brief. This workshop places you in the role of a junior network and security engineer who has just joined a mid-sized company. The infrastructure team needs to redesign and document the IP addressing plan for a new office site. Your job is to analyze a set of real-world network requirements, select appropriate subnets, justify your choices, and produce a clean, professional addressing plan document. This exercise directly prepares you for the reconnaissance and network mapping phases of a penetration test, where understanding the target's addressing scheme is critical. You will be given the following scenario. The new office site must accommodate 6 distinct network segments. Each segment has specific constraints in terms of number of devices, security isolation, and growth margin. Here are the segments and their requirements. 1. Management VLAN, 10 administrators, must allow up to 20% growth. 2. Developer workstations, 45 developers, must allow up to 30% growth. 3. C/CD and build servers, 12 servers, fixed, no expected growth. Or DMZ, public-facing services, 6 servers, web, API, DNS, must allow room for 4 more. 5. IoT and peripheral devices, 80 devices, must allow up to 25% growth. 6. Guest Wi-Fi, 50 concurrent users maximum, no growth margin required. All 6 segments must be carved out of the parent block 10.10.0.0 out of 16. You must not overlap subnets. Each subnet must be as tight as possible while satisfying the stated requirements. Step-by-step guidance. Begin by working through each segment independently. For each one, calculate the minimum number of addresses required, including the growth margin where specified, then identify the smallest CIDR prefix that satisfies that requirement. Remember to account for the network and broadcast addresses in your calculations. Document your reasoning for each choice. Do not just write down a result. Explain why you rejected smaller or larger options. Once you have selected a prefix for each segment, assign actual subnet addresses from the 10.10.0.0 out of 16 block. Work sequentially and verify there is no overlap between any 2 subnets. A good practice is to lay out all 6 subnets in a table with the following columns: segment name, required hosts, with growth, chosen prefix, network address, first usable host, last usable host, broadcast address, total usable hosts. Fill in every cell. Next, reflect on the security implications of your choices. In a paragraph of at least 100 words, address the following questions. Which segment represents the highest attack surface and why? How does subnet isolation contribute to limiting lateral movement during a breach? If an attacker compromised a host in the guest Wi-Fi segment, what does your addressing plan do or not do to prevent them from reaching the C/CD servers? This reflection connects your subnetting work directly to the penetration testing mindset you're developing throughout this course. Finally, produce a clean summary document, plain text, Markdown, or PDF, that contains your addressing table, your per-segment justifications, and your security reflection paragraph. This document is what you will submit. It should be readable by a technical colleague who is not present during your work. Clarity and precision are evaluated as much as correctness. Advice and common pitfalls. Do not start assigning addresses before you have calculated all 6 subnets on paper or in a spreadsheet. Trying to do everything in your head leads to overlap errors that are hard to detect. Use a binary or decimal scratch sheet to double-check your network and broadcast addresses. If you find that two subnets overlap, go back and reassign addresses rather than trying to patch the problem mid-table. For the growth margin calculations, always round up to the next power of 2, never round down. If a segment needs 58 hosts, 45 developers plus 30% growth equals 58.5, rounded up to 59, /26 gives only 62 usable hosts, which technically fits, but you must verify this explicitly rather than assuming. Be precise in your written justification. On the security reflection, avoid generic statements like subnets improve security. You are expected to reason concretely about attack paths, segmentation boundaries, and what a subnet boundary does and does not protect against. Think about what tools you have already used in this course: Nmap scans, Wireshark captures, and how subnet design affects what an attacker can discover or reach. You are allowed and encouraged to consult all previous course materials, the CIDR and subnetting lessons, the Nmap and Wireshark workshops, and any relevant internet resources. You may discuss your approach with peers, but the submitted document must reflect your own analysis and conclusions. The recommended time to complete this workshop is 3 hours. Submit your solution before the deadline expires.